In this video, we're going to talk about some of the basic math that we need for this part of the course. Don't worry, it's not going to get too heavy and we're going to keep it simple. So with that, let's just get started. First, I want to talk about logic. And in particular, I want to talk about Boolean logic, where all values can either be true or false. And there's no gray area, there's no middle ground. Everything is either true or it's false. Okay, and so as we talk about this, I want to have some abbreviations. I'm going to, for obvious reasons, abbreviate these as H and Z, so that as we go on, I don't have to write out true or false. Okay, so now, all right, I hope some of you at least are paying attention out there behind your computer. There is no possible logical reason why I would abbreviate true and false as H and Z. Let's abbreviate them as T and F, like normal people. All right, now, it's all well and good to be able to have values that are true and false, but that's not too interesting unless I can combine them in some way. So Boolean logic includes the operators not, and or. Now intuitively, I think you probably understand these from the definition of the English words of not, and or, and you can kind of work your way through what they mean, right? But I want to be mathematically precise here, so I'm going to give you the exact definition of these three operators. Now, if I have a variable that can take on a value, true or false, let's call it A. Okay. The question is, what is not A? And I'm going to draw a truth table to show you this. Okay, a truth table looks like this, where I show all the possible values of A, it can either be true or false, and I show you the value of the expression not A over here. So if A is true, not A is false. If A is false, then not A is true. Okay, and that probably makes intuitive sense to you, or at least I hope it does. Okay, so let's look at and or now. All right, so I don't have to just have one variable. I can have two Boolean variables, let's say A and B. And then we can look at what does A and B mean. Okay, so I've got more combinations now. A could be false, B could be false, or A could be false and B could be true, or A could be true and B could be false, or they both could be true. And that's it. Those are the four different combinations of A and B. Now, when I have A and B, intuitively you would think if A is true and B is true, then this must also be true. So let's put a true down here. Now, if either of them are false, then I can no longer say that both A and B are true. Therefore, the rest of these combinations here are false. Okay, and since I don't want to draw another truth table, let's just extend this one here, and let's look at the operator A or B. Okay, now A or B, if they're both false, hopefully it's obvious that neither A nor B is true, so therefore the thing's going to evaluate to false. But this expression is true in all of the cases because at least one of A or B is true. Okay, so if I have the Boolean expression A and B, it's true if and only if both A and B are true and false otherwise. And if I have the Boolean expression A or B, it's false if and only if A and B are both false and it's true otherwise. Okay, so hopefully this gives you an intuitive understanding of the different logical operators. And I want to point out that you don't have to have simple expressions that only include one operator. I could have, for instance, A and B, or C and not D. Okay, and so you can build these up in arbitrarily complex ways, and you have to evaluate them in the same way that we evaluated the simpler expressions. So you could build a big giant truth table, and you could actually figure out what is the value of this expression under all possible inputs. So we will actually use Boolean logic in our program, so let's take a look at how they work in Python. Okay, so I can have variables that take on the values true or false. So in Python, the words true with a capital T and false with a capital F represent these Boolean values. I can print them, right, and this is going to do the obvious thing. Okay, you can see true and false show up here. I can create logical expressions, so let's put a little separator there. I can print A or not A. I can print A and B and print A or B. Okay, so let's run this. And you can see when A is true and B is false, not A is false, A and B is false, and A or B is true. This all makes sense, and this is directly from the previous slide. You can go back and look at the truth tables if you're a little bit confused still. Now you'll notice that the Boolean logic operators in Python are the English words not, and or, and that's kind of nice because it's very easy to see what's going on here, unlike some other programming languages where they use more cryptic operators for these things. Okay? And I don't have to limit myself to simple expressions like that. I can do the complicated expression that we saw on the previous slide. I can print A and B or C and not D. Now I better define C and D to be something here. C equals true, D equals false. Let's run this, and you can see for this set of inputs, that expression evaluates to true. And I invite you to sort of walk through it on your own, make sure that you understand what's going on. All right? So this is how we use Boolean logic inside Python programs. So Boolean logic is interesting and useful in and of itself, but you don't always have true and false values lying around in your program. Instead, you end up generating them a lot of the time. Okay? And we generate them using comparison operators. Python has 6 comparison operators. It has greater than, less than, greater than or equal to, less than or equal to, and not equal to. And these 6 comparison operators allow you to take 2 values, compare them to each other, and generate a Boolean. All right, so let's try it out. Okay. So let's say A equals 7 greater than 3. Print A. Now, instead of just assigning true or false to A, we're assigning A to the value of the expression 7 greater than 3. And we know that 7 is greater than 3, so I would expect this to print true. And lo and behold, it does. Right? And there's no reason why I just have to have constants there. I could say x equals 8, y equals 5, b equals x greater than or equal to y, print b. Okay. Now I've got an expression involving variables, and x greater than or equal to y. I would expect that also to evaluate to true because 8 is in fact greater than or equal to y. And again, it does what's expected. All right. And since I use greater than or equal to here, I could actually change that to be the same number. It remains true. If I take out the equal, it becomes false. Okay? All right. Now, I don't have to just do comparisons on numbers. I can also do comparisons on strings. So I could say C equals hello equal hello. Right? Print C. What's going to happen here? This evaluates to true. Why? Because the text of the string hello is the same as the text of the string hello. And that makes good sense. All right, and I want to point out here that we're comparing the text, not the way you generated it. If you recall, we can have strings that use either single or double quotes, and that does not matter here. I'm comparing the text. Okay? So if I actually want to get it to evaluate to false, I have to change the actual string. Now when I compare, it's false. Okay, so it's important to remember I'm comparing the text, not the way that it looks. Okay, with the single or the double quotes. Now I also want to point something else out about this expression. Okay, there is a single equal sign here, and there is a double equal sign here. This is a source of a lot of errors for beginning programmers, and quite frankly, experienced programmers as well. The single equal sign is assignment. All right, so this means take what's on the right-hand side of the equal sign, evaluate it, and put the value into the variable that's on the left, in this case, C. All right? The double equals is equal. Tell me if the left and the right are equal to each other and evaluate to true or false. Okay? So try not to get that mixed up, although I'm sure that you will every once in a while. And most of the time, Python will give you an error, all right, when you mess it up. All right, I don't have to just do numbers or strings or integers or strings. I can do pretty much any Python type here. So I could say, hey, is 20.6 less than or equal to 18.3? Let's print D. Okay, so that should evaluate to false, I should hope. Okay, and this is now a good way of generating these Boolean values. Using these comparison operators, I can then combine them, with my favorite expression from before, and evaluate everything. Okay, with this combination of values, my expression evaluates to true. All right, so we're going to see this a lot in Python programs where you use these comparison operators to generate Booleans, and then you combine Booleans to try and figure out what you'd like to do next in your program. That ends our quick and painless introduction to the mathematical concepts of Boolean logic and comparisons. In the next video, we'll see how to use these concepts to build more interesting programs.